I was just going to go through a couple of things today. I think probably a good way to start will be just to mention this post I put out in Slack, which has got a link to an MP4 file showing running a simple path and then the program that I ran. I'll go through that in a little bit more detail. The path basically is going to, I press play here. So it starts this mission. I've got command velocity showing up here in the top right. It's going to come up here, make a slow circle, and come back down. You can see it travels at a good speed on a long straight. And then if you watch linear X, it comes down and stops before it gets to each one. So it's like this stuttering thing. I posted on ROS discourse. Has anybody got a solution to that? And although it's got a number of views, I'm still hopeful that somebody will come back with, here's how they did it. And you might have noticed there at the end, I just replayed that a little bit. It sort of backs up right to the next one. Yeah, see, you see linear X go negative, which means it's got to go back up to get there. If I just talk a little bit about the code that this is running. So in the lawn tractor repo, there's a few missions, and one of them is this drive straight, then do a U-turn. That's the one that you just saw the video on. And literally, creating this, which was a little bit of programming and a little bit of manual, and the manual I mean is when I go out and just comment out a couple of these positions, it's my attempt to smooth out the path. So it's pretty clunky the way to get a Dubin's path. But anyway, the code is there for anybody to take a look at. And of note, again, it is MoveBaseFlex and not MoveBase. So some of it's interacting with the simple action client. And anyway, so I think that's useful for anybody who's trying to run stuff, which I'll just point out. Part of the time in the last week has been spent coming up with missions that I want to run in the physical world and making them progressively harder. So this one point is literally just, showing how to send a command to the navigation stack. And then I will intend on running a 3-point line. And this is all obviously hard-coded positions, and these X and Y coordinates were derived by me, looking at my specific map. And so this is, again, a very hard-coded and simple mission. And probably after the 1 point and the 3 points, then I'm going to run the straight and do a U-turn. Also, I'll just point out while I'm here, this run in circular rotation. I put this here, which is a little bit more, it's going to execute these positions, was done to test, the turning radius and to make sure the physical turning radius matches what I'm seeing in the simulator. So in other words, in Gazebo, if this produces a 10 meter in diameter circle, then I'll be able to see in the real world, does this produce a 10 meter diameter circle? And I think it'll be just helpful as we go through the whole debugging process. Let's see, what else did I want to show? This, you might ask, so how did you calculate all that stuff? Well, one of the things that I think Jeff is going to talk a little bit about as well is some code that Juan and Matt had to produce a Dubin's path, and I took that and edited a little bit. And the reason I edited it was it seemed to be, I mean, the Dubin's calculation uses, it looks like 2 pi for 360-degree rotation. And heavens knows I don't always do things right, but I'm thinking in order to get my path to run smoothly, I wanted to use negative pi to positive pi. So in other words, these post statements, I mean, these are quaternions, but if you feed the Euler to radians or radians to Euler routine 6.28, which is 2 pi, you're going to get a positive number here. In my testing, I wanted to get a negative number there. And so the way to make that happen was to say, hey, if you give me something greater than pi, I'm going to calculate it to be a negative number. So anyway, just to point that out. It'll make sense to anybody who's in the middle of this and trying to create a path. But this is in the repo as well under simple Dubin's test, and I just have a folder here, code for testing, and it's not a part of the main source program app, but I put it in a public place so people can see it. That might be as much rambling as I want to do today. Let's see. 4 missions, simple Dubin's path. Oh yeah, there's a spreadsheet out in the repo called Vehicle Dimensions Helper, and it's primarily there because of this. Make that a little bit bigger. But I was just putting some other, basically me trying to figure out radians to quaternions and so on and so forth. So I thought I would just mention. And then I ran a circle using command velocity and captured the positions and was trying to confirm the, yeah, sorry, my phone is sort of blowing up here. So anyway, there's some testing data that's out there. Simple Dubin's path generator. I talked about that video, running the straight. And this is what I mean by the, these are the various points on, if you do 2 pi, then you get that's how you get 360 degrees. But like I said, on my path planning, I think I wanted all of these especially to be negative numbers. Okay, not rambling on my part. Sorry to be so long-winded. What's going on in your world? You're on mute, my man.
Okay. Since you're going through all this work to try to get a path from point A to point B and make it basically go where you want, I kept thinking, basically when you watch the thing running, and you're trying to drive a long distance, you can see that the global planner is constantly replanning, and it's not basically a straight line to where you want to go. And the other problem with the global planner is it's going to try to make a straight line from where you are to where you want to be, and it's not trying to do any smoothing of that or anything. And then if you turn it over to the TEB planner just takes that global path as a suggestion, and you can watch as runs. It creates its own global path, which is maybe, I don't know, 2 or 3 meters long, and then it creates the local path of where it's going to actually try to go to follow that. And just watching it, watching it drive from across the screen, it looks like it's not going out of his way to drive in a straight line. It just drives. And so I kept thinking, maybe going back to something that's just a little more to the point, like say the pure pursuit algorithm, where you give it an actual path, you give it a list of points, and it tries to follow those, and it tries to stay on that path. Now, I haven't actually run into this, so I don't know that that's the answer or not. But anyway, I was thinking about all that and remembering back that when Matt and Juan had started on Juan's lawn tractor, and I think the stuff that the Matt started with for the not Ag Open GPS, the Agbot challenge, when he took his lawn tractor, that I think at that point he was running with a pure pursuit follower and then somehow generating a path, possibly a Dubin's path. So I thinking about all that stuff, I went out, I was digging through the ROS agriculture GitHub, and couldn't find anything that told me what I wanted to know there. And it's got to the point where I can't find anything in that anymore. So I'm not sure if it's just me or if it's all hidden in a Docker file or whatever. So I kept thinking that I remember at one point people were saving their workspaces. So I put in the chat, there's a link. If you go to, let's do this, and do this, and do this. Come on. Oh, my computer doesn't want to work today. Okay, so if we pull up the Slack screen under the stored message, it's the pinned message at the top of general, and I did repost that later down below. But anyway, if you look at that message, it's a bunch of useful links. We come down here and it says under Google Drive folder, there's several things here, and the very last one says shared workspace copies. And if you click on that, I posted that link to the chat. If we click on that, this will take us out to Google. And under here we have, calm down. Boy, it's really not cooperating today. So under here we have 3 of these are from stuff that Al was doing, and one that I put a folder that's got 2 copies of my simulation stuff in it, depending on what I was trying to do. At the top of it says Poquito Project 2019. And I think Poquito is maybe Spanish for donkey or something like that. But anyway, that's Juan's project. So we go to Juan's project. And to the laptop sim. So I think let's it doesn't look the same as it did last night. So I thought it said before, it said desktop. Let me just try this and see what it does. See how far we get here. Catkin workspace, robot base. So we go to Catkin workspace and we look under source. That could be I'm in the wrong directory. You might have to start over here. So here's the one that says ROS Lawn Tractor. That's just the copy from ROS Agriculture that everybody has. It doesn't seem to have anything in it. So here he's got one called Pure Pursuit. So this is apparently the right directory. And So under pure pursuit, I think this is just directly checked out and put in his system as a package here. Trying to see anything down here that's important. This is just the stuff that comes with it. So we go to source. I should stop double clicking stuff. And the source is just a single CPP file. Come on. And this, as I say, I think is just directly out of the thing that's out on probably from the ROS wiki. It's just simply called it's the lyrics. Does that say at the top here? I think it's the lyrics pure pursuit. So if you go to the ROS wiki and you search for pure pursuit, I think this is what comes up. And basically, it looks like he just simply checked this out and put it on his computer. Since it's a CPP, you have to do a cat can make after you install this, and it's not very long. It's longer than I thought. But basically, I believe this simply subscribes to a path statement, and it will publish. One of the two I was looking at was one of them published both a command velocity and a Ackerman message, and I'm not sure why. I didn't look at it hard enough to do that. And the other one I'll talk about in a second here. I don't remember if it just publishes the Ackerman message or does something different. But anyway, so there is the code, and I assume it's probably directly from the repository for pure pursuit. So we'll go back up one level here. Oh, let me go back in there. So going to pure pursuit. That's weird. Sometimes I have to double click, sometimes I don't. So then there's one other file called, or directory called config. And there's just a single file in there. And I think it's just it's just a list of parameters. Well, that's not what I was expecting from that gen add. So it's just a small configuration file that has some stuff in there. And I think maybe the launch file, he's specifying more stuff to make this run. So anyway, that's all that's in that directory. So it should just be a matter of checking that out. What? Okay, let me bail out of there. So again, under pure pursuit, that's what he had. And then under his Poquito directory, the rest of the stuff is just to make the thing run. So the geodetic utils, that's something about converting positions, but the GeoNav transform is the one you need to have that loaded in order to be able to convert your GPS locations into your XY offsets. So that's what that is. And that's probably, again, just simply checked out and dropped on here. And his NEMA TCP driver is something for his Pixie GPS. Now this isn't the directory I was looking at last night, because it had one that was the ETH Pixie driver. But anyway, this should still get us close enough. So the bottom line there is, if you're going through this stuff, instead of picking the what I said Docker laptop, maybe I should have picked the one of the other two directories, because he's got three different workspaces saved here. So if I go to this Poquito, and under here it's got the under scripts. And I was used to seeing the big icons here, but anyway, we come down here. There's a bunch of just utility stuff going on here, and down here he's got these 3 Python programs, and the one that's called GPS heading.py. I believe that's the one that will load up that GeoNav transform. It will subscribe to your incoming latitude and longitude, and then it subtracts off your offset and publishes your XY final XY result. That's what that program is doing. And then no, I take it back. That's not what that one's doing. This one, the GPS heading, subscribes to the GPS velocity message, and then it takes the vector of X velocity, Y velocity, and does an arctangent on that to get the heading that you're driving. So this is the way to get heading from your GPS, is what that one's for. And then under there's one called Path Generator and one's called Path Publisher. So under path generator, I think it's just a single program here. And it simply takes, I think it takes a list of points that are in, you have a file, and the file was called, I think it's called something waypoints. We'll go look at that in a second. But anyway, it's just a program. Let's see, how do I scroll this? Well, there's my scroll bar. And it's not real long, but it's based on the Dubins, a Dubins path. See right here at the top, it says import Dubins. So there's a complete Dubins implementation that you can just import into Python, and you pass it. You say, here's where I am and here's where I want to be, and it returns back the segments to make a Dubins path. And then I think it's got some extended stuff where then in between those points, it generates a point like every, I think it's configurable like every 100 centimeters or something. So somewhere in there's code. I don't know if it's hard coded or you talk to it somewhere else. But anyway, it's just a standalone program. You run it. And if I back out of here, so one of the, say for instance, here's a waypoint to do a figure 8. Let's look at that one. So it's just a list of points that you want to drive to. So you go through, look at your map and say, okay, here's the points I want to drive to. You put them into this file and save that. And then you run that, generate points against that. And it puts out, let's see. Then it puts out the generated points. So here's one that says generated points, figure 8. So it took that first file we just looked at and expands that out to look something like this. So these are actual points along this path that you want to drive. So again, it's just a text file showing you what it created. Here, I'm getting the hang of this now. So
I can pause you. If I can pause you for a second, can you pull that back up? The generated waypoints. Yeah, see, scroll down just a smidgen. See those yaw values greater than pi? Like,
yeah.
That's the, yeah, when I was going through this code, that's where I discovered, hey, this is giving me yaw values greater than pi.
Okay.
Anyway, back to your review.
Okay, so once you get these generated points, you get this file with all these points in it. Then you've got another program here that will, it's called path generator. And this one, I believe it opens that file called generated points. And then it creates, it takes those points and builds a path message. So you basically say, create a path, give you a blank path, and then you iterate through all the points you've got there. Define that. So anyway, it takes all the points you had in that and generates a path message. And then if you're running, apparently if you're running the Pure Pursuit follower, it's subscribing to a path message. So you just simply, you publish the path, the follower says, oh, I've got a path now. So it just starts at the top and starts driving along that path until it gets to the end, runs out of points, and then comes to a stop. So, whatever you put in there, for whatever pattern you put in there, it should, start up, accelerate up the speed, and drive the entire path. I don't know if there's anything in here that controls the speed. I don't know if the Pure Pursuit is smart enough to know, oh, we're going to turn, so I should slow down, or if it just drives at a constant speed. I need to load this stuff up and try it and see what it does. So it looks like this one, so running this Pure Pursuit instead of the entire navigation stack, it looks like you can get your vehicle to drive around. Now, the other thing I was going to point out, I was saying that, you've got the concept of the waypoint file, and you've got the generated points file. Well, if we go back and look at our page on YouTube and come all the way down to the bottom here, the very first meeting we did after we moved from ROS Agriculture to this group. Come on. Should be this one right here. So this one down here is where the very first meeting I said, well, people can't figure this out. So I think I'm using the same program here in this file. Let me copy that, copy link, address, chat. So I think this meeting here, this video here, we were talking about how do you do this, and basically, you know, I just looked at the ground plot and said, if you want to drive, because the point was, let's see, how can I guess I'll have to open it.
I found out that there is the
Recording is on.
there is
I don't know if it's going to do me any good to come in here other than I should be able to find it here somewhere. I just want to get a bigger picture of what's going on here, but you can go out and you can watch the video and see what it is. So here I was saying, I came up with a way to do this, and then, so I just simply started with a file and I put in, like, I started right here, I think. And then I put in this point, I put in this point, I put in this point, and this one, and so forth until I got all the way to the end. And I ran that generate points program against that, and it put out a file that had the values in. I think that one actually maybe draws them right on the screen as you go. So it was probably generated an output file, and I don't think I was using that, but I think it's all the same software that I was using to do this. So in general, there is a way to, by manipulating where you put your points, get the vehicle to go where you want it to go. So that was what I was doing last night. I ran across that and thought it wouldn't be that hard to just don't start up the navigation stack in the simulation, the gazebo simulator that we have, and just load up this path follower and then run these two scripts. And I think it should have enough there to drive around. Like, say in this case, if you wanted to drive in this path here, you know, take whatever points I used to generate that with and create that and tell it to go, and it should drive around in this descending rectangle, I guess I would call that, constricting, whatever you call that. It's kind of a spiral rectangle, basically what it's doing. So theoretically, you start up one launch file, you could do this, or start up the other launch file, and it would get the original stuff with the navigation stack, and then you can click on the 2D nav goal to make it do that. So the other thing is, it could be that once this is started, you know, you got to see if I drop in the Pure Pursuit Planner and I create a launch file that says launch that. And I guess I could go back to where we were here, and then also under his stuff here, this is under the scripts. So he maybe has a couple other. I was gonna say maybe he's got a couple more utilities. I don't think he does. He just simply has the some waypoint files. He's got the output generated files, and he's got those three scripts. One which gets a heading from GPS, one which converts waypoints into generated points, and then the path generator converts those into a path and publishes that. Now somewhere, so I was watching one of the ROS agriculture videos, and somebody said you create this path and you can either publish that to Pure Pursuit or publish it to MoveBaseFlex, and MoveBaseFlex will honor that as a path and follow that. So I think at that point it's not going to attempt to slow down at each individual waypoint, but I don't know. I haven't tried that. So that's something to consider. What was my point? Oh, I was going to back up and show. So under his launch directory, so I was talking about the Pure Pursuit launch. Let's look at that one. So basically it just says the node is going to be Pure Pursuit, and then here's some parameters down here that he's put in. How come my screen looks funny? I can't figure out why it's wider there, but I guess that doesn't matter. So basically it just says here's the robot frame ID. So you're telling it the parameters it needs to know in order to make your vehicle move. And there should be a look. Here's a look ahead. It's a look ahead frame ID. Somewhere in the configuration files, there's this concept of look ahead in Pure Pursuit that you have to define. But this is basically just saying start the node up, and it'll just sit there and wait for something to happen. And down here, description, blah blah blah. So there's nothing really spectacular, but there is a launch file to start that. And then he's got
One more time, where's that launch file? Because that had a redirect from path planning to drive path, and I couldn't find that before.
Pure pursuit launch. So you're asking about in this file?
Yeah, see that right in the middle there, it says remap from path segment to drive path.
So that apparently is, so
That's really important because the script earlier was subscribing to drive path and I couldn't find drive path. And now I know why. It was a remap.
So I think drive path is probably what Pure Pursuit wants to see. It's just saying change the name of that topic. So apparently the program that says generate path, I think it was called, it's going to take the points and create something called path segment. Yeah, it's going to create something called path segment. But in order for Pure Pursuit to honor that, I think you have to rename it to drive path. So Pure Pursuit is subscribing to something called drive path. So you just have to make those match, is what that's telling you.
And what's the name of this launch file?
Well, everything's locked up on me again here. Hold on. Oh boy, oh boy. It's just something called Pure Pursuit launch. So if you go under his, again, so if you look under this is going to work under his Poquito package, or his entire thing here. It's got scripts, launch, and config. So just under launch there. Can I zoom in like this? No, nothing's working. So it's just something called Pure Pursuit launch is where the launch file's at.
Cool.
And then under, I was going to look at the other, since I just noticed there's one called config. Let's see what's in that one. Tractor YAML. Now I can zoom. So here's got things wheelbase, look ahead distance. So apparently this gets loaded in when you do that Pure Pursuit launch, it probably loads this file in. And so again, I'm not sure it's as streamlined as it could have been. So it could be it loads these in, but then the launch file is redefining some things. So you'd have to look at that and see what all that's doing. But anyway, so this is apparently the only parameters you need to get the Pure Pursuit planner to follow the path that you give it. And so back out of there. So I was going to look at these other launch files that he had. So we'll go back into his launch directory. And then the Pure Pursuit launch is what we just looked at. And I don't know what Poquito nav launch is. I haven't looked at that one. So we'll look at, here's got one that says .old. So I assume this is the current one. It says Poquito nav launch. So it starts off, he's loading a map. I don't know what it, there's probably no point to have a map server because if you don't have MoveBase running, nothing's going to use the map. So it could be that just left over. Fake localization, transforms these measurements in meters for your sensors. It's just setting up all the parameters on the vehicle, telling it where the GPS is and telling it maybe some sizes or whatever. And he starts up this program called GPS heading that's going to grab heading from his GPS. It says combines messages, combines heading from GPS velocity message and GPS fix. GPS to pose launch. I'm not sure. That's probably a program that will take your latitude and longitude and tell you where you are, but I'm not sure. So anyway, that's basically all the stuff is there. I assume this would work if you just put all the stuff together. And if I get around to it, I'll try this and I'll load this up and see if I can try to get the new gazebo simulator to drive around using this concept here. Because there's really very little stuff there to make it go. So that might be worth looking at. So I'm getting ready to move on to something else here. Any questions on all that stuff I was babbling about there. Post, don't want that one. So the other thing was last meeting. Let's see, how can I find that?
I was gonna have you pull up path follower again just one more time, but if you've closed it, don't worry about it.
The pure pursuit.
Yeah,
I can, let's see, I should be able to go back there for me to everyone. It's in my chat. So we'll go, it brings up the workspaces on Google Drive, and then come on, stop it. Then under Poquito project, which is Juan stuff. And then I was under this Docker laptop, and it could be that possibly the other directories might have some other fun stuff in there, you know, just doing it slightly different. The Docker sim maybe is going to be code that runs the stage simulator as opposed to the vehicle. So anyway, I'll go into this one that just, it was called the Docker laptop, and robot base and cat. Go into the cat can workspace. And there may be other things there I've skipped over that I just wasn't paying attention as I went through. We'll drill down to source. And so I think it was under Poquito. And there's the launch files. So I click on launch. No, you didn't want launch files. You wanted pure pursuit.
yeah, the actual script.
So we'll go into.
There was a pure pursuit folder, I think.
There it is. Come on. Oh, I guess I am in there.
Is that the one?
There's the actual code. Is that what you want to know?
Yeah, so see what it subscribes to.
It subscribes to sub ODOM and sub path. Wait, there's more stuff here. Let me see what else is here. Subscribe to path segment and subscribing to odometry. Looks like those are the two messages.
I think there's a Python script also that's similar. There was a path follower in Python too.
There probably is, yes.
Okay, no issues. I mean, I'll have to go back and look to see if there's. I
And
think I was spending time on the Python version and not the C++ version.
that's possible. But back to your point, you were saying that in the launch file, it was remapping something about the path, and then here it says this particular program is subscribing to something called path segment. It's just all that stuff has to match in order to get it to work. If one thing's publishing something, something else has to subscribe to the same name to get this stuff to connect. So that's why you ask about what's it subscribing to, and then here's the publish. So right here, it seems odd because on the next line down, it says it's going to publish a command velocity message. And then right below that, it says it's going to publish an Ackerman message. And I'm not sure what it's doing, that command velocity. It could be that's just a redundant thing. So if you want to just go, watch the command velocity, for instance, you could just echo that while it's running. Or it could be that it just makes it easier to run one type of vehicle or the other if it publishes both. So I'm not sure what that is. And if I get it running, then I can look into that and see what's coming out of those and see what to do with that.
Cool.
So let me go back to Slack. How do I get Slack to come up here? I think that was Slack. I go to random. I'll back up to the last meeting. Oh, I see I didn't get a link to this put into the last meeting, neither under chat or under the comments here. There's somewhere it says at 2350, it says Al found an implementation in Pure Pursuit. And he's pointing to this thing called github.com/F1. F1 10th, is that what it's called?
Yeah, it's a play on 1/10 scale F1 racers.
So under here somewhere there was one called just simply called Dubin's. All repositories. I'll get a searched, I suppose. Search. Find repository. I don't know if I have the right well, apparently I've got the wrong directory here. Let's see, back up. Okay, I say I've wasted a lot of time here, but so anyway, I guess it's not going to pop up. But the point was they're doing like radio control cars that they're putting ROS onto them, and then they in the title it says what is it? It says racing. So I assume they're trying to drive fast by doing this. So if you go follow that stuff down, they have I think again it's a single program that's called it's called a Pure Pursuit follower. And maybe that's why I can't find it. I was searching for Dubin's. I should have been searching for Pure Pursuit. Let me just give it one more shot here.
Take your time.
Okay, so I finally found that code and I posted that to the chat, and it's just under the F110th-dev, and the repository is called Pure Pursuit. And you can go look at that in the chat and find that. But anyway, this is another implementation of somebody path. I don't remember if it was under scripts or path. Vehicle controller. Oh, now I'm going to waste time trying to find this. Path. Huh. Anyway, I know it's here. I was digging through this and I found it. So launch path, RV scripts, sectors. I found the code and looked through it, and yeah, it does seem to be another Pure Pursuit planner. So this might be for the actual vehicle and not for simulation. I don't know if that would make a difference or not. But if I back up and look at launch file, we'll see what he's starting here.
I also noticed he has an interesting way of laying out his statements there. He puts name, package, type arguments all in the same coding structure.
Where are you seeing that?
The screen you just had up,
Uh,
instead of having a run-on sentence, he breaks it up.
oh,
Each one of those is an argument where
yeah,
I've
okay.
never seen it that way. It was a little bit like, what has he done here? And he's just taken a run-on sentence and decomposed it.
Yes. Node. So anyway, I'm apparently not in the right spot here because,
Well, it shows you the packages that he's firing up.
well, I suppose that would even tell me where they're located, wouldn't it? So we come down here, it says include that. Right where I was is node, nearest pose, adaptive look ahead, and those are in this directory, nearest global something. Pure pursuit controller, it's in F1/10 sim. Controller pi. So apparently that vehicle controller pi is his pure pursuit planner. So let me look at it one more time before I give up here. So this is one called vehicle controller pi, and it's not under the something sim that he told me it was going to be. So maybe this from Ackerman, import Ackerman drive, and we have a path. He's going to pose. So I think this is the is his pure pursuit followers. So that anyway, it's something worth looking at. It would be interesting to get this one running and the lyrics one both, and see how well they perform, see what features they have, and so forth. Yeah, because here he's building. I think right here he's building the this where it says right in the middle says curvature, steering angle. So this is doing the attempt to follow the path there. And then down here he said something about command, and he loads. The command is going to be his Ackerman command. Yeah, right here he generates. And I realize it's really annoying to watch somebody scrolling up and down on a file like this, but I'm just trying to find the thing here. So
I'm ecstatic that you're spending time on it. That's fantastic. You scroll away.
and somewhere above here it said create an empty topic of command, and then down here he's saying command.steering angle equals. So he's loading up looks like he's loading a fake message in there, and down below he's doing his calculations. It's right here, command speed. He's actually calculating a speed, and then down somewhere he says so he's putting the speed and the angle into an Ackerman message, and then the very last thing he publishes command. So that's publishing out the Ackerman message there at that point. So the other
again, this one is he's taking direct control with this. He's going right to an Ackerman message. He's not going to MoveBase or any other. Nothing's in between him and the low-level controller.
correct, just like the stuff that Juan has. He's not using MoveBase at all, as far as I know in that. So basically, you say, here's the points. It reads them and starts putting out Ackerman messages. And one other thing to consider is, do the Ackerman message being published, is it compatible with, say, what the simulator wants right now? Because the simulator wants to see a standard Ackerman message. And I put one note in there to convert that modified command velocity, just repackage as an Ackerman message, was just simply you wouldn't run that. And if this puts an Ackerman message out directly, this thing should this thing's going to publish that directly, and the simulator should use that directly. And if you get to the point where you want to do your physical vehicle, then we can decide, what to do there. If you want to just change it to an Ackerman message, or do we want to have a node that converts Ackerman message back to the modified command velocity or whatever. So that's just different things we can do. First, I just want to try to drop this into the simulator and see if I can get either one of these to drive around and do a reasonable job.
Can you keep that up, but then click on the link that I posted to the chat?
iPhone script sub.
This is Python script that's also in Juan's series of folders that is as
Okay,
the
well,
name.
well, this is Path Publisher. This is the one that takes, it reads up the generated points and generates a path message. So this goes between your generated points and your peer pursuit follower. This is another, this is what you run to make it actually move. So your peer pursuit follower is sitting there waiting for something to happen. If you run this program called generate points, let's see, can I?
This reads the generated points.
Yeah, this reads that file of generated points and just simply concatenates them together to create a path command. And then when it's done, it just publishes the path command. The peer pursuit follower says, oh, I just got a path, and it just starts following all those points until it gets to the last one, and it should come to a stop, I think. I've never actually run this, but I'm thinking that's how it's going to work.
In the C program that you had up earlier, it's going to read that path.
Yes, I believe so. Does that make sense?
It does.
So the scripts that he has there, the one that says generate points, is that what I think it was called, generate points. That's where you create a file and you put waypoints into it like that. The YouTube video that I published where we were talking about originally, you just simply put the points into that file and then you run the generate points. It reads the waypoints and creates the generated points output file. So that's just a manual thing that not necessarily in line. You could generate that ahead of time to generate your, say if you're going to mow your field or whatever, you could do that and create that file called generated points. And you're gonna have to get the name to come out right eventually. But once you have that file, then with everything started up and running, you got peer pursuit sitting there waiting for something to happen. You execute this Python script called Path Publisher, and it simply grabs the generated points file, reads all that in, concatenates that together to make a path statement, and then it publishes the path statement. And when it does, I should say path message. And when peer pursuit sees that, then it'll take off and start running. And this, it's all quite experimental, so it's not, meant to be a final product here, but that should be enough to prove whether or not you can generate a path and have this thing follow it and actually stay straight on the line and do what it needs to. I seem to recall that when they were playing with Juan's lawn tractor, they would generate using the Dubin's path generator, basically that generate points. They just put points and they said they'd have lines. Let me do this. And let me do this. Since I need to talk with my hands here, I'll get easier to see my hands. Okay, view, speaker view. So they created a file that there was a point here and a point up here. How come that's at an angle? Anyway, there's a starting point here and an ending point here, so it creates a straight line between there, and then it would draw a curve on the end for your Dubins, and then it would come back down to this point again. So by just putting a few in there, so it would follow that. But the thing is, somewhere there's some videos out on ROS Agriculture if I can find them, on the YouTube stuff. But it would start at the bottom here, and it would drive straight up. See, I have to go to the left to keep it looking straight. You get up here, and then it is supposed to go around the path like this. And you're supposed to follow that until it gets back to this point and then draw a straight line down again. Well, what it was doing, it was cutting those points. So as it's trying to go around the curve, it didn't go all the way around the curve. It's because of the way peer pursuit works. I don't know if it's because, I assume it's it's trying to keep your base link on the line, the path that you've specified, and not the front of the vehicle. So the front of the vehicle just turns early and doesn't go around that full path. So that's something that'll have to be looked at and figure out what to do about that. But again, just get it moving in the first place, and then you can start seeing what the problems are. And I hope you can still hear me. I got a message saying I have low system resources, which may affect my audio quality. So we'll see what this does.
You never blanked out on my side.
No, that's good. It's complaining. I don't know if that means I got too many things running or if I'm out of disk space or out of memory or whatever. I don't know what that means. So anyway, that's the thought I had on that, that this was running at one point, and when we watched the videos and watched the screenshots, you could see that the vehicle would move down to the end of the line in a straight line. As it goes to turn, it would cut the turn short, but it would come around and line up and hit the line going straight, going back the other direction. So that's just something that, by tweaking it, I think you can figure out how to get around that and make it go exactly where you tell it to. So what'd you just publish there? What'd you just post?
The link to this file, which was, some rudimentary instructions on using some of those. You were trying.
So apparently, yeah, that's what we ran at the time to create that. So you've got instructions there on how to do this stuff.
Right. But what I neglected to include at the bottom of this was, let's see if these instructions are any good. Using the generated waypoints. This was in the simulator. Launch Docker. See, it wanted to use that Python script. And then there was this path follower script.
And possibly you can feed this path directly into MoveBaseFlex. So with what you've got, if you just publish that as a path, as opposed to publishing poses, that may actually run. But I think in the long run, you're not going to be happy with TEBplanner and Global Planner, to get an agricultural vehicle to go from point A to point B where you want it to go. But that might work.
I think I'm right there with you. After hacking it, so to speak, yeah, it's unfortunate, but I think you're right.
But the problem is, if you throw out MoveBase, now you're throwing out lots of handy things, like it was maintaining your map of your world in your global map, your global cost map, and it was reading sensors and updating your local cost map, and it had a state machine to figure out, it's waiting for a goal to come in. Once it gets a goal, it says go fire off the global path planner, so it goes out your global cost map, figures out how to drive around through there, and returns that path, and that path was then passed into the local planner that would go ahead and drive around. So if throwing all of that out, well, then you're gonna lose all that stuff. So at one point I was wondering, could you load up MoveBase and let it run and let it say maintain your map, let it read sensors and build the local cost map, and not actually let it do any navigation, so we could have something running in parallel, say that's running this pure pursuit follower, and it's doing all of the navigation, but you still got all the stuff in MoveBase running, so you still have access to your map, you've got access to your obstacles on your local cost map, and so forth. So that might be another way to do that. But it's just going to take some experimentation, I think, to figure that out.
That's why I was curious to see what it was actually publishing, and yeah, so it would be nice to not throw out the whole thing.
I kept thinking,
Anyway,
well, it might be nice to put, say, Pure Pursuit as a local planner into MoveBase, but the problem is it's gonna directly follow that global plan. The global plan isn't meant to be a nice smooth path to go where you want it to be. It's going to attempt to just draw a straight line from where you are to where you want to be. And you pass it over to Pure Pursuit, well, yeah, it might follow that, but when you get to the end, it's not going to try to line you up to be going the correct direction you want, and so forth. So if you're going to put Pure Pursuit into MoveBase as the follower, then you probably want to replace the global planner with something that does a better job as far as creating a nice smooth path to go where you want it to. So again, there's lots of different ways to approach this. So I think that's all I had that I, you know, I run across, found out where to find this stuff. And um, again, what's that last thing you just posted on? You just showed me what it was. It was the definition of using that generate points and so forth. So that's again, that's all I have. And if I get some time, I'll go download Juan's stuff and put onto the simulator and see if I can get that to move, and see if it's going to take something weird to get the message types to match. And there may be require some more translators from, you know, say if it is for some reason publishing command velocity with Ackerman, you need a node to do that. But I think it's putting out Ackerman directly, so that should work. There is that thing about he was taking heading from his GPS, and technically, probably if you just fire that up if all the names match, that will take the heading directly from the simulated GPS and generate, because I assume it's the, so if something wants heading, it's probably the pure pursuit follower, and it could be that's just left over from something else. It doesn't, it may not need heading at all. So that, again, that's just more stuff to look at and try to track down each one of those things.
So that all sounds great. I thank you for spending time on it. The next thing that I was going to do is crack open my radio control embedded code and program it so that the mode switch sets a data element that says the, you know, whether I'm following command velocity or whether I'm letting the radio control drive it. And then I've got to change that on the tractor control as well. So that's the next thing for me, is to update my low level controller, getting ready to test those simple missions out in the yard. That's all I got.
Okay,